Okay, let's move to the next topic under permutations and combinations. Next concept is permutations under conditions. So how to calculate the permutation under certain conditions? So there are some rules to be followed to calculate the permutation under certain conditions. Okay, let's look at the conditions one by one. So condition number one. Okay, this is the number of permutations of n objects, comma, are taken at a time. The condition is when a particular object, has to be added in each arrangement. In each arrangement, one of the object has to be added at any cost, right? So if that is the case, at each arrangement, that is given by R into n minus 1 P R minus 1. Okay, that's the first point to remember. I just have to remember this value, right? We will use it in problems. Next one, the number of permutations, of n different objects or n different things, comma, taken are at a time, comma. Now the condition we give, so that is when P number of particular things to be always included. To be always included in each arrangement. In each arrangement, right? So this is, now you see previously it was only one object. Now P objects are used always. Okay, so that means it is P factorial multiplied by R minus P minus 1 raised to the, P factorial into R minus P minus 1, okay, into, this is n minus P, capital P times R minus. So when it is 1, the previous answer, R into n minus 1 pr minus 1. But when there are p different objects supposed to be repeated, this is the equation. That is the equation. That's a second point. Okay, then the third point is that the number of permutations of n different things taken are at a time. Now the condition is that when a particular item is never taken, one of the item is not going to be taken at all, it's never taken, that will be written as n minus 1 PR. Next, point number 4. The number of permutations of n different objects taken are at a time when n number of specific things, n number of specific things always come together, right? If m number of things are always coming together, then this is the answer. The how many permutations are possible? That is equal to m factorial, multiply that with n minus n plus 1, so many factorials. So that is the answer. Okay, next, fifth one. Here, the number of permutations of n different things taken all at a given time, and the condition is that when m specified items never come together. So if you want to calculate that particular permutation, then the answer will be given by n factorial minus subtract m factorial into n minus m plus 1 factorial. Okay, that is the answer. N factorial into n minus 1 plus 1. Okay. So let's try to solve the problems based on these 5 different points. Okay, so they're very important and very easy to solve because we already have the equations. simply substitute and get the answer. Okay, so the first problem based on this particular concept is how many permutations can be made out of letters of word triangle, out of which how many of these will begin with T and end with P. Okay, so the word triangle has 8 letters and all the 8 letters are different. So the part A answer is nothing but the total number of permutations possible with the letters of the word triangle is 8 factorial. So 8 factorial is 40320. That is part A. Then we have a part B, right? So now you see there are 8 letters out of which the T is fixed, E is also fixed, which means remove T and E from that. How many are remaining? There are 6 remaining. Only those 6 letters can be arranged at different positions, right? So the answer for the part B is 6 factorial, right? So the 6 factorial is 720 is the required answer. Okay. The next question. In how many ways can the letters of the word insurance can be arranged so that vowels are always together. So the problem statement says that you have to consider this word called insurance. Let's write that first and we'll see. So this is IN. So let us try to mark down the vowels required. That is I, E, A, and E. Okay. Now I want to make sure that they are always together, right? So let me make sure that all of them are together. So I'll write them together. I, U, A, E. This has to be together always. And remaining letters, let me write. Remaining letters are, that is N, S, R, N, C. Okay, now consider this whole thing always together as x, right? So my uh, letters, now what I have is some x. Internally x can contain 4 letters. Let's deal with that later. So x, n, s, r, n, c. How many ways you can arrange this? What is the number of permutations that is possible for this? That is 6 factorial. Size is 6, out of which 2 are repeated. Correct? 6 factorial divided by 2 factorial. This is the first thing. Next, now let's come back to this x. That x actually has I, U, A, E. Now you see there are 4 letters. All the condition says that they have to be together, but in which order, that they are not specifying. So this can actually happen. The I, U, A, E can be permuted among themselves in how many ways? 4 factorial. So total required answer is this and this. So whenever you say and operation, right, you know the basic mathematics we discussed at the beginning. Whenever two of them are happening together, you will multiply, right? So therefore, right, the final answer, therefore the total required permutation equal to 6 factorial by 2 factorial, multiply that with the 4 factorial. Okay, just try to get the answer for this. So multiply that with 4 factorial. So when we solve this, we get this is equal to 8640 is the right answer. All right. Next question. How many words can be formed with the letters of the word Pataliputra without changing the relative positions of the vowels and consonants. So in the original word Pataliputra, wherever you have a vowel, you have to have a vowel, but you can actually mix up from other vowels present in the same word, right? So similarly, wherever you have a consonant, you have to write a consonant only. You cannot put a vowel over there. In this fashion, how many words can be arranged is the question. Okay, so as we can see, the word given here is having 1, 2, 10. So totally 11 letters. Okay. So out of which I can see that everything is almost repeated. There are 2 P, right? There are 3 A, and I think 2 T, 1 L, 1 U, and I have 1 R and 1 I. Okay. 1 R and 1i. Okay, so 2 plus 3 plus 2. Okay, total 11. All right. Now you see, right, we are not allowed to change the position of a vowel given uh, in the given text or in the given the word. So wherever you have a vowel, you have to keep a vowel, but you mix, right? You can bring any other vowel into that position. Similarly, wherever you have a consonant, you have to retain a consonant, but T can come to the position of P can go to the position of L, etc. That's fine. Now, so first let us say, what are the vowels? Vowels are 3 A's and 1 I, 1 U. So totally I can see that there are 5 vowels. So 5 vowels, in how many ways you can arrange 5 vowels? That is 5 factorial, out of which 3 are repeated. So 3 factorial. Okay. So there are 5 vowels. You can arrange it in this fashion. Next, okay. This can be done in 5 factorial divided by 3 factorial. All right. So this is 5 factorial divided by 3 factorial. Now, let us say we have 5 factorial by 3 factorial. I think this is 20. In the next session, ಹೇಳಮ್ಮ. ಅಷ್ಟೇನೋ ಬರಬೇಕು ಮೋಸ್ಟ್ಲಿ 36 ಬರುತ್ತೆ, 3600. Yes, yes, yes. Okay. Now the remaining letters, right? That is how many consonants? So 6 consonants, correct? So in how many ways you can arrange the 6 consonant? 6 factorial divided by, there are 2 repeated P's and there are 2 repeated T's. So 2 factorial by 2 factorial. I think this is 180. So yes, therefore, since it is a AND operation, like 5 vowels can be arranged among themselves and 6 consonants can be arranged among themselves, right? So the answer becomes equal to, right? Therefore, this is equal to 3600, that is equal to 180 into 20. Next question. Next question. Find the number of ಹಲೋ ಹೇಳಿ. ಹಲೋ ಹೇಳಿ. ಹೌದೌದು ಹೇಳಿಣ್ಣ. ಓಕೆ ಓಕೆ. ಹೇಳಿ. ಓಕೆ ಓಕೆ. ಬ್ಯಾಟ್ರಿ ಅದು. ಹೌದಾ, ಓಕೆ 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 ಓಕೆ. ಆಲ್ ರೈಟ್ ಆಮೇಲೆ ಇಲ್ಲಣ್ಣ, ಸರ್ವಿಸ್ ಇಲ್ಲ. ಸರ್ವಿಸ್ ನಾನು ಇತ್ತೀಚೆಗೆ ಯಾವತ್ತೋ ಮಾಡಿಸಿದೆ, ಒಂದು 2-2.5 ತಿಂಗಳ ಹಿಂದೆ. ಸರ್ವಿಸ್ ಹೌದು, ಹೌದು. 2-2.5 ಲೋಕಲ್ ಅಣ್ಣ, ಲೋಕಲ್. ಅದು ಯಾವುದಪ್ಪ ಹೆಸರು ಇವಾಗ ನೆನಪಿಲ್ಲಣ್ಣ. ಯಾವುದೋ ಇದು ಅಷ್ಟೇ. ಹಾ, ಹೌದಾ? ಹೌದು, ಹೌದು. ಹಾ, ಹಾ, ಹಾ. ಓಕೆ, ಓಕೆ. ಓ, ಹಾಗೆಯಾ? ಬಟ್ ಅದು ಈಗ ಬೇಡಣ್ಣ. ಮೊನ್ನೆ ಅಷ್ಟೇ ನಾನು ಸ್ವಲ್ಪ ಖರ್ಚು ಮಾಡಿದ್ದೀನಿ ಇದ್ರ ಮೇಲೆ. ಸರ್ವಿಸಿಗೆ ನಾನೊಂದು ನಿಮ್ಮ ನಂಬರ್ ಸೇವ್ ಮಾಡ್ತೀನಿ. ಒಂದು 2-3 ತಿಂಗಳು ಬಿಟ್ಟು ನಾನು ನಿಮಗೆ ಕಾಲ್ ಮಾಡ್ತೀನಿ. ಅವಾಗ ನೋಡೋಣ. ಆಯ್ತಾ? ಹ್ಮ್. ಹಾ, ಏನಣ್ಣ? ಯಾವ್ದು? ನಂಬರ್ ಪ್ಲೇಟ್ ಹೇಳಿದ್ರು. ಅದೇ, ಅದು ಕೂಡ ನಾನು ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಮಾಡಿಸ್ತೀನಿ. ಸದ್ಯಕ್ಕೆ ನ- ಹೌದೌದು, ಗೊತ್ತಾಯ್ತು ನನಗೆ. ಹೌದೌದು, ಹೌದು. ನಿಜ, ನಿಜ, ನಿಜ. ಬಟ್ ನಾನು ಆಕ್ಚುಲಿ ಗಾಡಿ ತುಂಬಾ ಓಡಿಸಲ್ಲ ನೋಡಿ. ಈಗ 15 ವರ್ಷ ಆಯ್ತು ಗಾಡಿ, ಬರೀ 50,000 ಓಡಿದೆ ಅಷ್ಟೇ. ಬರೀ ಒಳಗಡೆಯಿಂದ ಹೋಗ್ತಾ ಬರ್ತಾ ಇದ್ದೀನಿ. ಸದ್ಯಕ್ಕೆ ಹಾಗೆ ಸ್ವಲ್ಪ ಖರ್ಚು ಕಮ್ಮಿ ಮಾಡೋಣ ಅಂತ ಅಷ್ಟೇ. ಓಕೆ. ನಾನು ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಮಾಡಿಸುವಾಗ ಅದೆಲ್ಲ ಒಟ್ಟಿಗೆ ಮಾಡ್ತೀನಿ. ಒಂದು ಸರ್ವಿಸ್ ಮಾಡಿಸ್ತೀನಿ, ಪ್ಲಸ್ ಅದು ನಂಬರ್ ಪ್ಲೇಟ್ ಕೂಡ ನಾನು ನೆಕ್ಸ್ಟ್ ಟೈಮ್ ಮಾಡಿಸ್ತೀನಿ. ಓಕೆ. ಹಾ, ಹಾ. ಓಕೆ, ಅಷ್ಟು ಮಾಡಿಸಿ ಒಂದು ಡೆಲಿವರಿ ಕೊಡಿಸಿ. ಹಾ, ಆಯ್ತಾಯ್ತು. ಆಯ್ತಣ್ಣ, ಆಯ್ತು. ಓಕೆ, ಓಕೆ. ಆಲ್ರೈಟ್. ಹಾ, ಆಲ್ರೈಟ್. ಸರಿ, ತುಂಬ ಥ್ಯಾಂಕ್ಸ್. ಓ, ಸಾರಿ, ನಾನು ನೋಡಿರಲಿಲ್ಲ. ಜಸ್ಟ್ a second. Okay, this is a question. Find the number of permutations that can be uh, had from the letters omega such that, okay, we have some conditions. Omega such that, so first part is O and A occupy the end places. The second part of the question is capital E uh, is always at the middle. Then vowels occupying the odd places. Then the last question is vowels not used. Sorry, vowel not used together. All right. This is the question. Please try to solve this. Is right. Second is right. This is coming 24. So vowels occupying odd places. So that there are three vowels which can be arranged in odd places, three ways. Correct? Not three factorial. Correct? First, third, and fifth position can be arranged in 3 factorial. Also, you can see that there are two consonants. Correct? So two consonants can be arranged in 2 factorial. Correct? So 3 factorial into 2 factorial is the answer, because they yes. So the answer is 12. Perfect. So the vowels are not together. Okay. So vowels are not together means, okay, let's try to do the calculation. So this means, first consider what is the total number of words. Let me write that. So total words is 5 factorial, correct? So 5 factorial, that is 120. Right. Now, let us say that vowels are together, and right, when I write the vowels together as X, so you have the words X, M, and you have the letters X, M, G, right, where X consists all the vowels, right? So if this is the case, how many ways you can do that? This can be done in 3 factorial, correct? Vowels together, if you keep, the total number of words equal to 3 factorial, and X itself is nothing but the what are the letters O, E, and A, right? They can be internally, you can, right, you can arrange in another 3 factorial. So totally, how many words can be made together with the vowels together is equal to 3 factorial into 3 factorial, correct? Are you okay? So this is actually 36. Now the question is, how many words can be made together without vowels being together? So the answer is, so required answer is 120 minus this 36, because 36 is vowels together. From the total number of words, if you subtract the number of words where the vowels are together, you get the answer, right? So the answer is equal to 84. So there are 84 ways in which, right, you can make the words where the vowels are never together. That is the required answer.